Hi guys, this is my second video about the symmetry properties of the unit circle, and this time I'm going to be working through this example from the JAC Plus textbook, and I'm going to be showing you how to move the triangles around the unit circle. So here we have just one piece of information. The previous example we had two. We had one which had an alpha and a theta angle. So this time it's just theta, so we don't need to worry about choosing the correct one. So what I've done, I have drawn this situation. So here's my triangle in the unit circle, my right angled triangle, and this red line here is representing the cos of theta, because of course the cos of theta is the horizontal base length of the triangle there. So that equals 0.5300, and I might actually write that on there as the decimal, 0.5300. All right, so that's the length we have here. So now we need to find the sine of pi on 2 minus theta. And people find this a little bit tricky because we're not dealing with the triangles being part of the butterfly. So in the last video I talked about when you draw triangles in the unit circle, it makes a butterfly or bow tie, so you always draw them like that. But this time it's not going to be the case. So here, the sine of pi on 2 minus theta, let's see where that goes. So I'll draw another unit circle over here, and pi on 2 is here. And this time we're going back by theta. So actually now the triangle will exist like this. So I've taken this yellow triangle and I'm putting it in a different orientation there. And over here I've actually copied the triangle and moved it into different positions so that you can kind of see what we're doing. So I'm going to put this triangle onto the unit circle. Look, it's not going to be exact, but we'll just pretend that's nice and neat. So what we see is that the red line that used to be the cos of theta has now moved up here. So that's where the red line is. And actually, if you just look at the triangle there, you can see that that red line is still there. So the blue line, which I've drawn here, is on the top, and the red line is now on the side. So let's now answer the question. It says the sine of pi on 2 minus theta. So we're talking about this point here. And if we were making a triangle as part of the butterfly, it would be this triangle. So the angle would be in here, but we're not looking at that angle. So this point here, we have to look at the y value of that. And we can see that the y value is represented by that red line. So here, this line here represents the y value of that point. And we can see that that is 0.5300. And furthermore, we can see that that is positive because the y value for that point would be positive. So we've considered what the size of the angle or the size of the line is, the length of it, 5300, and we've considered that it's positive. Of course, you don't need to write positive there because we assume it's positive unless it has a negative, but I will just to show that we have considered that. So look, let's look at the next one, which is cos of 3 pi on 2 minus theta. And I might actually put it here as well. And this time, well, I'm not going to be using this triangle anymore necessarily, so I'll put that back over there. Let's draw a unit circle. And now we're going to go to 3 pi on 2 and we're going to subtract theta. So this is pi on 2. This is 2 pi on 2 or pi, and this is 3 pi on 2. So we go 3 pi on 2, and we're going to be subtracting theta, so we go back a little bit there, back to around there. So I'm going to draw that. And this time my angle of theta is in here. So this is what makes it a little annoying because this is why it's not part of the butterfly. I need my triangle to be like that. So now we need to consider which shape of the triangle we're going to use. And what we can see is it's actually going to be this one here. So when it moves around, it's going to sit in there like that. So I might just actually put it onto this one here because it's going to fit a little bit better. And Now we can say, well, there's theta, there's the right angle there, and we're looking for the cos value. And what we can see is the cos value is represented by the x coordinate of this spot here. So it's this length here. So in other words, it's the same as this. So I can find what the value of that blue line is by using Pythagoras, and that's what I'm going to do. So I want to know this length here, which corresponds to this here. So let's see, here's my triangle. I'm just going to draw the original triangle. This is 1 because of the Pythagorean identity. The radius of a unit circle is 1 unit. We know that this is 0.5300, and we're trying to find this. So I'm going to call this A, and this is going to be, well, A squared equals C squared minus B squared. So A squared equals 1 squared minus 0.5300 squared. And then, well, if we solve that on CAS, A is going to equal plus or minus 0.8480. So I put the plus or minus there because, well, I'm square rooting, so that means it's plus or minus, but also because in the unit circle we could have positive or negative values for sine and cos respectively. So in this case, where we see it here, well, this is going to be positive because on this point, we're in the positive of the y-axis there, and that's our sine value, so it's positive 0.8480. And, well, that means that this length, this blue length here, is also 0.8480. But what we need to do is decide whether that's going to be positive or negative. So we're looking at a cos value there, so 0.8480. So you can see that the sine value, when the triangle is in quadrant 1, turns into the cos value when we put it in this orientation in quadrant 3. So now, here is the x value of the point, and that length is represented by 0.8480, and it is negative because it is in the negative zone. So if you're not sure, think about a normal Cartesian plane. That point would be somewhere here, and your x value would be negative. X value corresponds to our cos value. So what we get is negative 0.8480. Okay, so let's go to the third one, which is a tan 3 pi on 2 plus theta. So tan of 3 pi on 2 plus theta, and that's all in brackets. And let's now see where that's going to be. So I'll draw it over here. Now, when we're working with tan, as I showed you in the first of these symmetry property videos, tan equals sine over cos. So let's first draw our picture. So here is pi on 2, here is 2 pi on 2 or pi, and there's 3 pi on 2. And now we're adding theta. So we go around to 3 pi on 2, and then we add a little bit more, and that little added bit is our theta. So again, it's a little annoying because this angle means that our triangle is not part of the butterfly. So usually when we draw the triangles, we put it as part of the butterfly, but in some of them we have to, put it so it's in a different orientation, and these are a little bit harder. So now we need to decide how we're going to put our original triangle. So let's go back, and it's going to be this one here. So I'm just going to drag that over. Oh, doesn't want to come. Here we go. All right, so I'll put that onto there. It doesn't want to really fit in the right spot, but we can see how it is. So I'm just going to put it there. So you can still see the orientation of the triangle, and you can see the red and blue lines. So remember, the blue line, that line there, on this, when we refer to ours, that is 0.8480. And then the red line, well, that is now going to be here. That red line is 0.5300. So we can see that if there's a point here, well, our x value, which is given by the blue, well, that's positive. So it's positive 0.8480. The y value of that point, well, that's going to be negative because it's in the negative zone for the y-axis, or well, the sign. So that's going to be negative 0.5300. And now, well, we can say tan of 3 pi on 2 plus theta is going to be the sine. So our sine value, we said, was negative 0.5300 over our cos value, which is positive 0.8480. So we can already see that the value is going to be negative. So that will equal tan 3 pi on 2 plus theta equals, and you just obviously do that on CAS, it's going to be negative 0.6250. And they're asking us to do in 4 decimal places, or in any case, our given angle is in 4 decimal places. So it's important that you use 4 decimal places for your answers, even if they are zeros. So even in the example, they give us the reference angle of 0.5300. So it's important that we always write those 2 zeros on the end as well.